Welcome to educator.com. This lesson is about dividing rational numbers. In this lesson, you will learn to divide rational numbers, and we will be dividing fractions, integers, and decimals. Some applications are to determine how to divide up portions of food, or to determine how to divide up amounts of money. Vocabulary for this lesson includes reciprocal. A reciprocal is when two numbers have a product of 1. For example, A over B times B over A equals 1. A reciprocal of 1/3 would be 3 over 1, since 1 times 3 is 3, and 3 times 1 is 3, which equals 1. In the case of 3 over 1, we would say the reciprocal of 1/3 is 3. Let's try finding some more reciprocals. The reciprocal of 2 over 3 would be 3 over 2. The reciprocal of 8, which as a fraction would be 8 over 1, is 1 over 8. And when there's a negative, such as a negative 1/2, the reciprocal would be, including the negative, negative 2 over 1, or just negative 2. Remember, because a negative times a negative would give us a positive, and we want the product to be a positive 1. Let's try dividing some rational numbers. In dividing fractions, you will need to use the reciprocal. So 2 over 3 divided by 5 over 7. You're going to take the reciprocal of the second fraction, this one, and it becomes 2 over 3 and 7 over 5. And once you've taken the reciprocal, the division becomes a multiplication. We can't cross simplify 2 and 5, and we can't cross simplify 3 and 7, so we're going to go ahead and multiply straight across. 2 times 7 is 14, and 3 times 5 is 15. Lastly, we'll check if we can simplify, and we can't, so our final answer is 14 over 15. To divide negative 2 and 1/3, we're going to change the negative 2 into a fraction. So it will be negative 2 over 1. Then we'll take the reciprocal of the second fraction and make it into 3 over 1. Once we've taken the reciprocal, division becomes multiplication. Negative 2 times 3 is negative 6. 1 times 1 is 1. And simplified, that's just negative 6. Next, let's take a mixed number, 2 and 2/5, and divide with the decimal, 6.2. I'm going to take the 6.2 and change that into a fraction. So 2 and 2/5 divided by 6 and 2 over 10. The 2 over 10 will simplify to 1/5. If you forget how to change decimals into fractions, you can review a previous lesson. Now when you divide mixed numbers, you have to change the fractions into improper fractions. 2 times 5 is 10, plus 2 makes 12 over 5. 6 times 5 is 30, plus 1 makes 31 over 5. And, we haven't taken the reciprocal yet, so this is going to stay a division. Now let's move it to the side here. 12 over 5, I'm going to take the reciprocal of the second one, which becomes 5 over 31. And now the division becomes a multiplication. I see here I can cross simplify, which will make my number smaller and easier to work with. 12 times 1 is 12, and 1 times 31 is 31. And that is in simplest form, 12 over 31. So when dividing fractions, if you have a mixed number, you must make it into improper. Let's try dividing rational numbers in word problems. You have a 6 2/5 pound bag of chocolate peanuts to divide evenly among 5 friends. How many pounds of chocolate peanuts does each friend get? So let's say take 6 2/5, and we're going to divide that by the 5 friends. We're going to change our mixed number into an improper fraction. 6 times 5 is 30, plus 2 is 32 over 5. And we're going to divide by 5, and we'll change that into a fraction by putting it over a 1. Next, we're going to take the reciprocal of 5 over 1, which is 1 over 5. And since we've taken the reciprocal, our division now changes into multiplication. And we can multiply straight across. 32 times 1 is 32, and 5 times 5 is 25. And let's change 32 over 25 back into a mixed number. 25 goes into 32 once, leaving us a remainder of 7. So that becomes 1 and 7 over 25 pounds. So each friend gets 1 and 7 over 25 pounds bags of chocolate peanuts. Let's try an extra example, and we're going to be dividing decimals. 23.8 divided by 3.5. You cannot divide when there is a decimal in the outside portion. So what we're going to do to get rid of this decimal is to move it over one place value. What we do to the outside, we have to do to the inside. So this gets moved over one place value as well. So now our new problem becomes 35 into 238. We're going to estimate. 33 goes into 100 about 3 times, but 35 is a little bigger than 33, so I'm going to estimate it into about 200. So let's say 6, 35 times 6, and give it a try. In this case, the only thing you can do is guess and check. So 5 times 6 is 30, 18, 19, 20, 21. Okay, that looks pretty close. So 210, let's subtract 8 and 2. Put a decimal here, bring down the 0. Into 280, I'm going to try now, let's see, 210 into 200 leaves 70, so it looks like we're going to be able to go in perfectly 8 times. Let's give that a try. 5 times 8 is 40, 24, 25, 26, 27, 28. Works out perfectly. So it'll go in 8 times. So 6.8 is our answer. So 23.8 divided by 3.5 is 6.8. So as a recap here, you cannot divide when there is a decimal on the outside of the division box. And once you move the decimal out, you need to do the same place value movement on the inside. Let's try a fraction divided by a decimal. Oh, nope, we're still dividing by a fraction here. So fraction, a mixed number divided by a negative fraction. Excuse me. All right, so when we're dividing fractions, if you have a mixed number, you need to change it into an improper. 5 times 8 is 40, plus 3 gives us 43 over 8. And we're going to be dividing by negative 1/4. When dividing fractions, you must take the reciprocal of the second fraction. So that means we're going to flip it upside down, and we're going to be working with negative 4 over 1 now, and the division changes into a multiplication once you've taken the reciprocal. I can diagonally simplify by 4, making my number smaller and easier to work with. 43 times 1 is 43, and 2 times 1 is 2. And remember, don't forget about your sign. A positive times a negative is a negative. Let's change that into a mixed number. 2 will go into 4 twice. Bring down the 3. We'll go in once. The remainder of 1. So our final answer is negative 21 and 1/2. Let's try dividing rational numbers in a word problem. The search committee was able to cover 24 miles in 4 3/4 hours. How many miles was the search committee able to cover in 1 hour? So if I want to find 24 miles covered in 4 3/4 hour and change that into 1 hour, I'm basically finding a unit rate. So I'm going to divide 24 by 4 3/4. That will get me down to 1 hour rather than the 4 3/4 hours. So 24 as a fraction is 24 over 1. I'm going to change this into a fraction. 4 times 4 is 16, plus 3 is 19 over 4. Take the reciprocal of the second one, so that becomes 24 over 1 and 4 over 19, and the division becomes a multiplication. So now I can multiply straight across. 24 times 4, 4 times 4 is 16, 8, 9, got 96 on top, and 19 on the bottom. And let's see if we can change that into just miles. So we have 96 and 19. It will go in about, let's say maybe 5 times. 19 times 5 is 45, 5, and 9. Very close. The remainder of 1. So 5 and 1 over 19 miles per hour. So just a little over 5 miles an hour. A landscaper is building a 75-foot fence to border a tract of land. If he places a stake every 2.5 feet, how many stakes will he need? So we're going to divide 75 by 2.5. I'm going to change the 2.5 into a improper. 2 times 2 is 4, plus 1 is 5 over 2. And this 75 becomes an improper fraction as well, over 1. And then I'm going to take the reciprocal of the second fraction, and that makes it 2 over 5. And the division becomes a multiplication. I can cross-simplify here and get my numbers a little smaller. Oops, 75 divided by 5 goes in once. It goes in 5, so not 25, but 15. It's always better to check your work than take a guess there. 15 times 2 is 30, and 1 times 1 is 1, and that simplifies to 30. Now, this is a very important problem to go back and read your answer, to go back and read the question and check your answer, because what they're saying is there's going to be a stake every 2.5 feet. Now, in applying that in a real-life situation, you know that the fence has to start out with a stake as well. So although the stakes come every 2.5 feet, see if we were doing this every 2.5 feet until you hit the end and so on, notice that you need to add an extra one to the front. So instead of 30 stakes, which is what the math tells us, we need to think in the real-life application the fence has to start out with a stake as well. So it would use 31 stakes. Thank you for watching educator.com.